Hello, Hornets, and welcome. Thank you for joining me today. I'm very happy I'm able to once again bring you some more videos after a little bit of a respite. We're going to be talking about parametric equations. Now, parametric equations are actually a very easy concept. I want you to think about physics for a moment. We have a car, and that car is moving off of a cliff. Well, what's going to happen to that car? See, right now it currently has a horizontal momentum, but gravity pulls it down, right? We would expect it to be pulled down the further it goes, so that the car's trajectory is a downward curve. We say this is a curve that is increasing at an increasing rate. Okay, and when you get to calculus, you'll see this curve again. Now, each of these components, this one, which is our y in terms of t, our x in terms of t being horizontal, excuse me, and our y of t being vertical. And what we're now doing is we're saying that as we move through time, two different things are happening, a vertical and a horizontal. Okay? Now we could easily convert this into three dimensions and start talking about it as a vertical, horizontal, and a sideways, right? Moving sideways. So let's see what we do. We're going to take a very, very simple equation. I'm going to take x equals t, and I'm going to take y equals negative t squared divided by 3. Now all I'm doing here is graphing, okay? How do we graph today? Now, the way we're going to graph is we're going to make a table, and we're now going to have, instead of just two values, we're going to have three. We're going to have time, we're going to have x, and we're going to have y. Whoops, and that y I just wrote backward. Sorry about that. There we go. Now, we're going to go ahead and we're going to think about this in terms of an infinite domain, because you'll notice no matter what value I have here and here, my domain is the same. So I don't have to worry about that right now. So I'm going to do negative 1, 0, 1, 2, 3, 4. Now be aware, I started with time at negative 1. Technically, time doesn't exist going backward, but I'm just going to go ahead and I'm going to use this just so that I can get an example of a table of values similar to what you started with when you were working in the equations that were functions. So you'll notice I'm now going to put my x, then I'm going to put my y, then I'm going to put my x, then I'm going to put my y, then my x, then my y, whoops, and that is negative. Then I'm going to do my x and my y, then x, then y, then x, then y. And you'll notice I now get a table of values, and it's from this table of values that I'm going to graph. So we're going to use that table of values now to graph on a plane. You see, what's interesting about parametrics is that parametrics can go up, down, left, or right, and we have to keep track of the direction that we're moving. So we're starting at negative 1, negative 1/3. Now keep in mind, I'm not going to put all of these on my graph, because I'm not going to have enough room for you to see everything. But it should be enough for you to understand. So I've got negative 1, negative 1/3 to 0, 0, back to positive 1, 1/3. Then I have 2, 4/3, 3, negative 3. Now you'll notice the graph started here according to my information. Now I could have kept going backward though, because technically, once again, for the moment, we're letting time go both forward and backward. You'll notice I'm getting a parabola. I'm going to put a ray that just shows the movement. Okay? So over time, this is the way this graph moved. Now, I can interpret that since it looks like it's a quadratic with an axis of symmetry at the y-axis, that there has to be a point over here as well, and another point way down here over here. And that this parabola is going in both directions. Okay? But notice, the movement based on time is up and then down. Okay? And that's how we graph a parabola or any other function, no matter what it might be. For example, it could be trig. Here, let's take a look at a trig function. Let's say that we have x equals 3 sine t, and we have y equaling 3 cosine t. The table that I'm going to have to make in terms of time will now have to be radians. So I'm going to have x, t, x, and y. And because I'm using trig, I'm going to start with 0 pi. I'm then going to go ahead and I'm going to do a pi over, let's do a pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and I'm going to squeeze one more all the way over here. Woo! Put that all the way in, and we're going to say that this is what, 7 pi over 4. Last one would be 2 pi. All right, let's see what happens. I put in 0, sine of 0 is 0 times 3 is 0. But look over here, that's going to give me a 3. This is going to give me root 2 over 2, so 3 root 2 over 2, 3 root 2 over 2. This is now 3, but this is now 0. Now I've got a negative for my, well, positive. So still 3 root 2 over 2, but notice this one's going to be a negative. 3 root 2 over 2. Then pi, well, let's see, that's going to give me a 0 again. That's going to give me a negative 3. Interesting. Getting a pattern here. Negative 3 root 2 over 2. And this is negative 3 root 2 over 2 again. Then we have negative 3, 0. And then we have our positive 3 root 2 over 2 and a negative, negative 3 root 3 over 2 for the sign, and a positive 3 root 2 over 2. Well, isn't this fun? Now notice, these are going to be the easiest ones to graph, aren't they? We call these the ordinates. I mentioned this to my students when we were working with our trig values. It's just going to give me a 0 for the sign again, and it's going to give me a 3. So if I just use 90 degrees for this, I can get an idea of what this graph is going to look like. Let's go ahead and graph it now. X is 0, y is 3. That's up here. Then we have 3, 0. X is 3, y is 3. Now notice, this is going around like this, and at pi over 4, we're sitting right there. And then we have 0, negative 3, so we're now down here. Again, that was our middle point. Then we're going off to negative 3, 0. So my x is negative 3. My y is 0 again. Curve comes around like that. Once again, that's that point. It's a little flat. And then I do it here. Wow. That's what we call a circle. Huh. So this is a circle centered at 0, 0. And it's got a radius of 3. Well, that's remarkable. I wonder if there's a way to convert our parametric equations into rectangular equations, which is where they started from. So this is how we graph, whether it's got trig in it or whether we're looking at specific values. We can restrict them. So I could do specific x values or time. So I could say our time goes from negative 5 to 5, or time goes from 0 to infinity. Both of those are restricted domains. One is finite, the other is infinitely restricted, but still, we can do that. All righty. Thank you for joining me. I hope this helped. And we will continue to graph things, and we will continue to convert from our parametric into rectangular and rectangular into parametric. Be well, take care, and see you later. Bye-bye.